My dear friends, we are in the topic of generator protection. I was telling to you that there will be at least 10 videos of about 30-40 minutes each to complete the generator protection, because generator protection is a complex protection. We have started talking about only one protection, that is generator differential, and we are going ahead into that. We were talking that the main thing is to, or rather the important thing is to calculate the value of stabilizing resistance, very critical value of stabilizing resistance, so that relay is sensitive for internal faults, because stabilizing resistance is going to insensitize a little. That is not a big problem, because as such the system is feeding the current to the fault. So current I2 coming from the system is reversing. So it's not a big issue. But more important is it should be stable against external fault. If just after CT2 out of the zone, because between two CTs is the zone of protection. And if the fault occurs after second CT, that is very severe fault, because it's only the subtransient subtransient direct axis reactance that limits the current, and that is very low. See, therefore the current is very high. That requires the proper calculation of the stabilizing resistance in high resistance differential protection. No doubt, low differential protection is also high. Low resistance differential protection is also used by numerical relay manufacturers. We will see that also when we talk about numerical relay in differential protection, right? But right now, the normal way. So we take an example of 210 megawatt. It comes to 247 MVA. If I consider 0.85 power factor, a design power factor, 15.75 kV is the generator voltage, and 9050 ampere is the full load current. Through fault withstand given by the manufacturer is 10 per unit. 10 times 9050, 90,500. It can withstand for a small time, right? So you have to consider that current as a fault current for deciding the value of stabilizing resistance. XD dash, that is transient direct axis transient reactance, but we will not consider that. We will consider XD double dash, because differential protection operates very fast within a cycle. So we will consider the worst case. X2, X0 are given, not required for differential protection calculations. XS is also not required here. XS will be required when we think about the backup bow protection. But these are the details of the generator. CT is what we are using is 10,000 by 5. 10,000 bar 1 you can't use, right? It is a very big ratio. So 10,000 by 5. The KPV, we are purchasing the CT KPV is more than 350 volt. We are purchasing these CTs. And RCD is less than 1.5 ohm. Therefore, we will consider 1.5 ohm. CT secondary resistance. Lead resistance is 0.4 ohms. I mean, I've taken a typical case, typical geography of Ukai power plant, unit number 5. The relay setting calculations I had done. So that exact value from the layout which was given to me, I could find out the lead resistance. So going further, relay we are using is rated current is 5 ampere. Obviously, relay rating and CT secondary rating are same. Setting range is 5 to 20% of 5 ampere. Burden is 0.9 VA to 1 VA. So we will consider 1 VA. Neutral grounding transformer. We don't need in calculating differential protection calculations, but just given this 50 kVA, it's a distribution transformer. 50 kVA, 15.75 kV to 240 volts, single phase, 50 hertz, because it is used in neutral, so it is single phase. Earthing reactor is air core, air cooled, no special cooling is there. 3 millihenry and 50 hertz. 145 ampere is the current that it can take, and 240 volt is its voltage rating of the earthing reactor. Generator differential relays we will set 5% to 10%. So we select 10%. We don't go up to 5%. To better select sensitivity. That sensitivity is not required also. So 0.5 ampere. It is clear that in this case, the relay will not be able to detect earth fault. That I was telling to you last time. Because the fault current for the earth fault at the terminal of the generator will be 0.25% of rating of generator. You see, Zn that you have used is 3 millihenry. So Zn is 2 pi f L. L is 3 into 10 raised to minus 3. And that when seen in primary side is 15.75 into 10 raised to 3 divided by 240 raised to square. It will be square type. So it will be seen as 4059. I was telling roughly 4000 ohms. So IF that you find out for the terminal fault, if the fault occurs somewhere at half of the winding, then it will be at less, but terminal fault is 15.75 into 10 raised to 3 into root 3 divided by 4059, because IF is equal to Z1 plus Z2 plus Z0 plus, 3 EPH into Z1 plus Z2 plus Z0 upon plus 3 ZF. So Z1, Z2, Z0 are so low, 0.2, 0.2 and 0.5, 0.1, that with reference to 4059, you can ignore them. And therefore, the fault current comes out to be 2.24 ohms, which is roughly 0.25% of generator rating. 0.25% of 9050 ampere or 10,000 ampere. You see, 10,000 0.025 means what if you calculate for 100.025, then for 10,000 roughly you say, then 10,000 by 100 will be 100 into 0.025, 2.5% of generator rating. 2.5% of 10,000 ampere if you calculate. You see, that current is in primary once again. That current is in primary. That is 2.5% of 10,000 will be 2.5 only, I think so. 2.5%. 100 into. So this such a small current cannot be sensed by any differential protection. So differential protection, which we are talking about, is reserved for double line and triple line faults only, and not for uh, line to ground. Line to ground, we will have to talk separately. And that is what I'm telling, that generator protection is a little complex protection. Then R step formula, we have seen IF RCT plus RL divided by IS. IF is 9050 into 10 because 10 per unit divided by 2000 CT ratio 45.25. Burden is RR is burden divided by I square because IS square RR is burden. So that comes out to be 3.6 ohms. Therefore, R step, if you so calculate, will be 168.35. And we consider 1/3 of that. So we will connect 60 ohms of resistance. So that is what we have decided. That was our business. And knee point voltage of the CT should be 2 VR. VR is 45.25. That is the fault current, 1.5 plus 0.4, RCT plus RL, 85.975. And your KPV should be 85.975 into 2. See, into sign, symbol multiplied by is typographical mistake, is mistaken here, but 85.975.2, 975 into 2 is approximately 172. But we have purchased the CTs, the KPV of which is more than 350 volts. It should be more than 172 volts. No problem. Our CTs are correct. So we have purchased good CTs. We have calculated the value of the stabilizing resistance also. If you go to numerical approach, they are using low resistance differential protection and not high resistance. That is bias differential relay they use. And they use the differential relay which gives two different slopes. So the characteristic consists of three parts. One is A, which is sensitivity threshold, or so often people call it basic setting. Right? Minimum current that is required to pick up the relay. B is slope 1, taking care of avoiding maloperation of the relay due to CT errors. Because there will be normal CT errors plus or minus 3%. So that is taken care of by curve B. But curve C takes care of maloperation due to mismatching of CT saturation characteristic. So it is higher slope, right, to save the maloperation against mismatching of the CTs. So any point above this curve is operation. Any point below this curve is blocking. Right? What is the philosophy they use? They said that I differential is equal to I1 minus I2. Mod I1 minus I2. And they said that I step is mod I1 plus mod I2. So if I differential is more than K times, K is settable. And there are two Ks, not only one slope, there are two K. K times I step, class A protection is initiated. That is how the numerical relay manufacturers are giving. They are using this low differential protection, right? So that is about differential protection. That is how you can calculate the value of stabilizing resistance for differential protection. Only for double line and triple line faults. So we have talked about only one kind of fault. So it's only two kinds of faults. Triple line as such, if you see, triple line is just impossible. Double line, there is a little possibility in overhang portion. So when differential protection operates, I was telling to you in one webinar that differential protection in one case operated because burning of the uh, burning of the that where the connections are made, you see, that connection point, two CTs points, I mean, at one side were shorted. The terminal block was burned, and therefore one side CTs were shorted. Second side CT were then obviously feeding the relay. So it was not an internal fault. Terminal block burned. In other case, I was telling to you that there was an earth fault outside the zone of protection of generator. But because of that, there was a flashover within the zone of protection between two phases because the voltage exceeded. So when differential protection operator, good maintenance engineer, never doubts the generator winding. Very rarely. It is next to impossible if I say so. Then I'm not wrong, you see. I have not heard of any, so to say, forced outage because of the failure of really the insulation between two windings, because it is very nicely manufactured. It's a very big generator. It's a very costly generator. But yet, the protection engineer has to be ready for whatever, because you cannot lose a generator. You cannot, I mean, uh, uh, the cost of the generator is so large that you cannot wait for the generator is completely damaged. And also, while you are repairing, you are losing revenue. So differential protection is very fast, one cycle, very fast. Everything will be faulty. So that is differential protection. With that, my dear friends, I end today's talk. I do not want to lengthen any talk. You enjoy small talks so that you can read, right? 20 minutes, 30 minutes, one can hear and gain knowledge at no cost. But share this name of Adapt.me, because my viewers, as I've always been telling, my viewers are the ambassadors, my ambassadors, because we do not have big advertisement campaign. We do not have. We are just starting. It's a startup. So the viewers, if you think that you are getting something new, if you think that you are getting a knowledge from a protection expert, I don't say that I'm number one. I may be number 100, but from a protection expert, you are getting the knowledge. If you think, then you are my ambassador, and please share this to as many people as you can, and tell them to hear the video so that our viewers, our likes, our subscriptions are more and more people in the world know. Many of my student friends know me. So my student friends are certainly my first line ambassadors. But my second line ambassadors, I'm seeing in LinkedIn nowadays that my second line ambassadors from different countries are coming up. I would request all of them to continue the practice and let this name of Adapt.me be spread in the world. Right now, Adapt.me modules are available throughout the world. 3 modules are already uploaded, but you have to pay for that. And the 4th module on distance protection is on way. But till then, these videos are at no cost. So with that, my friends, thank you very much and goodbye.